Hello and welcome to Lab 4 of our machine learning series. So in Lab 3, we trained a churn prediction model using SageMaker's built-in XGBoost. Ran a hyperparameter tuning job to find the best configuration and what else? Evaluated it with accuracy, precision, recall, and F1. And we ended with a trained model artifact sitting in S3. So today we are not retraining anything. The model is done. Now it's about operationalizing it, taking that trained artifact, turning it into a live service that a real application can call, and then we'll deploy it as a real-time endpoint, test it with actual customer records, and configure auto scaling so it can handle changing traffic without any manual intervention. So this is the difference between a data science project and a production machine learning system. A model sitting in S3 helps nobody. A model behind an endpoint that a CRM or a support application can call in real time, that is where the business value lives. So let's go into it. So understanding the lab architecture, again, before we go into any code, let me explain 3 concepts that are central to today's lab: the model object, the endpoint configuration, and then the endpoint. So these are 3 separate things in SageMaker, and understanding the difference matters. So the model object is a SageMaker resource that pairs 2 things together: the trained model artifact from S3, which is this tar.gz file we produced in the other lab, and the Inference container, which is basically the Docker image that knows how to load that artifact and serve predictions. The model object does not run anything, it's just a definition. And then we have the endpoint configuration, which defines how the endpoint should be deployed. Things like which model to use, what instance type, how many instances, the traffic weights if you have multiple model variants. Again, this does not run anything, it's a blueprint. Now, it's the endpoint that actually runs the service. It's going to read the endpoint configuration, provision the instances, in this case, loads the model, starts accepting the prediction request. So this is what costs money while it's running. So in our code today, the SageMaker SDK handles the endpoint configuration creation automatically when we call model deploy. But it's important to understand these layers exist, because when things go wrong, maybe wrong container, wrong S3 path, wrong schema, knowing which layer the error is in is going to tell you exactly where to fix it. So let's go ahead and get started. We are going to work with a new data set. The customer churn deployment lab data set. Let me see if I have it available. So, this is the data set that you're dealing with. Has like 120 rows, 10 columns. The churn rate is approximately 42%, slightly lower than the day 3 dataset. And what you can realize is this dataset has the categorical columns that are not yet encoded. So things like the contract type, internet service. So these are text values. Our day 3 model was trained on one hot encoded versions of these columns. So before we send this data to the endpoint, we need to encode it the same way. So as usual, again, we need to go back to S3, upload the file, and we'll work with that. So just an overview as well. So under S3, so I'll still use my bucket. Now this could be the deployment. We have the deployment lab folder. Under it we have data, and then the CSV file. So just to create that as well, I can show you. So you create a folder. This will be the deployment lab. And then inside it, you can create another folder. Call it data. And then inside data, we can go ahead and upload a file. Okay, so simple as that. And next step, so we have to get a notebook. So still you go under SageMaker AI, you click on SageMaker Studio, open Studio. It's going to take you to this specific page and you need some compute running. So once you have that running, you can just click open and it will take you to such an environment as well. And you go ahead and create a notebook. So choose just Python 3 kernel and then give it a name, and yeah, you can just rename it to, something like lab 4, churn dataset or deployment, whatever, and rename. And we are going to work with that. So here's my notebook available. So let's take a look at what we're doing here. So the first part is basically the setup and retrieving our model artifact. So what exactly is happening over here? Okay, we have the SageMaker session and get execution role. Same setup where we are establishing our connection to SageMaker and getting the IAM role that has permission to create and invoke endpoints. Something new, we have the SM client. This one gives us a low-level Boto3 client for SageMaker API calls. So we need this to look up the training job details. What else? So we do have the SageMaker, best job. So this is the name of the best HPO training job that we got from day 3. So we had got this because we know which job produced the best model. What else? Yeah, describe training job. So describe training job is an API call that returns all the details about a training job, including where it was saved, where it saved the model artifact. So it's going to extract the S3 path for us. So when we run this, basically we are expecting to see the model artifact path printed. Yeah. So, and remember the prefix for lab 4 is going to be deployment lab, not modeling lab, like the one we did in day 3. So just pointing out from the new notebook. So let's see. So here it is, just the same thing. And okay, so the next thing is basically to prepare our data. So load and prepare the data set that we have available. And over here, you can see we are downloading the data set from S3 into the notebook environment. We are expecting like 120 rows by 10 columns. So, and you remember the data set had categorical columns as we showed before as text values. So if we send these type of values into our endpoint, it will fail with a 400 error because the model does not know what to do with strings. So this is one of the most common deployment mistakes. The inference payload doesn't match the training schema. So the model was trained on a specific set of numeric columns in a specific order. Every prediction request must match the exact schema. So we need to encode this data set the same way our lab 3 did. So in the next cell, is to encode, is a one hot encode to match like the 3 model schemas over here. This is it. So, and the next cell is over here to one hot encode to match the 3 model schema. We drop the identifier and the target. We never send these values to the model as well. And then the day 3 model expected these exact 15 columns in this specific order. So that is what you are defining. We can add any missing columns with 0 and reorder. So that is basically it over there. PD get dummies converts each categorical column into multiple binary columns. So one per unique value. And then, yeah. And then, yeah, we rename and reorder to match the exact column names that the lab 3 model was trained on. Reindex is going to ensure that the columns are in the right order and is going to fill any missing columns with 0. So that's it. If the shape or columns are wrong, the endpoint is going to reject the payload. So that is this part. And here you can see what you're doing. So we're able to download our data set and encode that as well. And you're seeing the results. The output shows 120, 15. So all 15 column names are matching the lab 3 schema. So now the next part is to go ahead and deploy our endpoint. Let's take a look at the code as well. So here is a sample of the code that we're using. And let me walk through this carefully because there are important decisions over here. So we can see over here, retrieve, XGBoost, the region and the version. So we want to get the same XGBoost container image we used for training. And this is important because the inference container must match the training container. If you trained with XGBoost, let's say version 1.5, and then you try to serve with 1.7, you might get compatibility errors. So always use the same version. And then we do have the endpoint name. Yeah. So we set a fixed name. It's just for demos in this case. If the deployment call fails, you can always reconnect to the endpoint by name without hunting what is its identifier. And then we do have the, let's say, model.deploy as well. And over here, you can see wait equal to true. That means that the cell is going to block until the endpoint is fully in service before moving on. So this is going to prevent our next cell from running before the endpoint is ready. And then we create a predictor object separately rather than relying on the return value of deploy. So I'll explain why it's more robust. The predictor connects to the endpoint by name. So even if we restart the kernel, we can always reconnect without deploying. CSV serializer means we send the data CSV text. JSON deserializer means the response comes back as a passed JSON object. And this takes like 3 to 5 minutes as well. So moving on to the code. So this is the code I ran before. No big deal over here. I was just trying to print the endpoint name, but it was able to deploy. And this is the code I shared with you. Yeah. From SageMaker, the endpoint name, the model, and then how to connect to the endpoint, this code. You can run this cell as it is alone. You don't need to run this one. It's just a copy of this one as well. And it just is connected to endpoint, and it connected me to, the endpoint, which had like the best model. So that's it. This takes place as well. You can go to SageMaker as well, and you can go to endpoints, and you'll definitely get an endpoint being created here, and you can wait for it to be in service as well. So yeah, If it's in service, that's your signal. The model is loaded and ready to accept the requests in that case. So you can see the endpoint details as well. It will give you information like, let's see. We can see the logs being collected there. You can see the settings over here, the configuration details, everything you need to know about that specific endpoint. Okay, so now the second part is to test inference. This is the fun part. So we are going to send a couple customer records just to test. Let me show the code first. So here we send like 3 real customer records to the endpoint and see what the model predicts. So before we run any code, let me ask you to think about these 3 customers based on what you're seeing over here and predict which one is most likely to churn. Okay, I showed some answers already. But thinking about it, we have case A. Customer A is a 28-year-old customer who has only been with us for 4 months, paying $100 per month on a month-to-month contract. They are using fiber optic internet and they have no tech support. Customer B is 57-year-old. They have been with us for 46 months. They are paying $64 per month on a 2-year contract as well. Using DSL, they do have technical support. And then we have customer 3 who is 35. They have been with us for 18 months, paying $88 a month on a 1-year contract as well. And they use fiber optic with no tech support. So if we think about the signals we discussed in Lab 3, short tenure means less commitment. Month-to-month means no penalty for leaving. High monthly charges can drive dissatisfaction. No tech support means when something goes wrong, the customer has no help. And fiber optic customers in our data set tend to churn more. So basically, case A has almost every high-risk signal stacked together. Case B has almost every low signal, a low-risk signal. Case C somewhere in the middle. So here we are just trying, in each case, is a list of 15 values in the exact order that the model expects. And we convert each list, into a comma separating the strings and send it to the endpoint. So what you are expecting back, so after you run that cell, here is what we basically got back, with customer A being a high risk, B and C being low risk. But you can see C has a notably, higher risk than B. So the model ranked them exactly as expected, and this validates that the model has learned the right patterns from the training data. This is the kind of interpretation that, a business analyst will bring to a churn prevention team. The model will give you a number, and now it's your job to explain what that number means in terms of customer behavior and what action to take. So this is it. And now the next part is, now that our endpoint is working as expected, did a nice job with prediction, is to configure auto scaling. So right now our endpoint has exactly 1 instance, and that means that if traffic suddenly spikes, let's say a marketing campaign runs, thousands of customers need to be scored simultaneously, that 1 instance is going to be overwhelmed, so causing slow responses. And if traffic is very low, then we are paying for capacity we don't need, and auto-scaling solves both problems in that case. So SageMaker endpoint auto-scaling uses AWS Application Auto Scaling, the same service for ECS, DynamoDB, and so on. And it works in 2 steps. So you can see the first step, we register a scalable target. And then the next step is to attach a scaling policy. So what do we have over here? Okay, So service name space is equal to SageMaker, just tells the application auto scaling that was scaling a SageMaker resource. The resource ID identifies what exactly we are scaling, the endpoint name and the variant name. So the variant name is all traffic by default when you deploy a single model. So if you have multiple model variants, let's say for A/B testing, each variant will have its own name and it could be scaled independently. Scalable dimension specifies that you are scaling the instance count, not memory or CPU, but the number of instances. And then minimum capacity, the endpoint always has one instance running, even if the traffic is 0. And then maximum capacity, that is a cost control measure. Without a maximum, a traffic spike will spin up like dozens of instances and generate a large unexpected bill. And then we attach a scaling policy. So we can see policy type, target tracking. So we have two types of scaling policies, step scaling and target tracking. Step scaling, you're defining your thresholds manually. Target tracking is simpler because you just tell it what metric value you want to maintain, and it figures out how many instances are needed to achieve that. So for beginners, I think target tracking is always the right choice. We have said a target value of 70, meaning we want to maintain 70 invocations per instance per minute. So if the current instance is receiving more than 70 requests, SageMaker will add another instance. If traffic drops and each instance is receiving fewer than 63 requests, SageMaker will remove an instance. We do have SageMaker variant invocations per instance. It's just a built-in CloudWatch metric that SageMaker publishes automatically for every endpoint. So we don't need to instrument anything. It's already being tracked. Scale out cooldown 60, meaning after adding an instance, wait 60 seconds before considering adding another. So this is going to prevent rapid overscaling. And scaling cooldown means after removing an instance, wait 5 minutes before removing another. So scale in is more conservative because if we remove instances too aggressively, it can cause latency spike. So that is basically what the code is about. Let's go back, and it's simply this. We register our target and then we attach a scaling policy. And once you run that and you go back to SageMaker under endpoints, so you check the endpoint, the latest endpoint, and you can see all details, of course, the metrics. And under settings, you're going to see the runtime settings. For example, over here, the current instance count is 1 and the instance type is MLM5 large in this case. And it can be from 1 to 3, and we have set up automatic scaling. And when you go to alarms, if there are any alarms that have, occurred, they will be available over there. So that's it. Yeah. So right now we have no alarms. Basically, it's normal because no major traffic has hit the endpoint. So that is what you'd show a stakeholder to demonstrate that the endpoint is production ready. Okay. So just to wrap this up, we're done. So yeah, just a few reflection questions. What is a real-time endpoint? Why is a real-time endpoint appropriate for this specific use case? Because any business application needs instant prediction for like one customer at a time. So when a customer agent opens a customer record, they need to know immediately whether that customer is at churn risk so they can adjust their approach. So that requires a synchronous, low latency response, and real-time inference delivers that. When to use batch inference. So if you need to score many customers at once and latency doesn't matter, for example, maybe a nightly job that scores 3K customers and generates a churn risk report for the marketing team the next morning, but Inference is going to be cheaper because it uses spot instances and doesn't require persistent endpoint. And how does auto scaling help performance and cost? During peak hours, let's say a Monday morning when the support team start their shift and the CRM is making hundreds of prediction requests, auto scaling adds instances to keep response time fast. During quiet period, think overnights or weekends, it can scale back down to the minimum. So you are not paying for idle capacity. Okay, so and remember to clean up as well. So you don't pay. So always delete the endpoints when you're done. And the cleanup, just simple code. Yeah, you remove the scaling policy first, and then you deregister the target, and then you finally delete the endpoint itself. And that's basically it. Okay, thank you.